Hello everyone. Today we are continuing talking about creational design patterns and we cover the singleton. Now, when you would like to use this pattern? Well, first of all, when you need one and just one instance of an object, one can argue you can use some global variable, sure, but in this case you are losing OOP properties. Next, you would like to have lazy initialization, which is creation on demand. If you don't ask for it, you don't get it. And third is when you would like to have a global access. Now, when to all these 3 points you say yes, it's probably a good idea to consider a possibility of using singleton. Of course, many programmers would argue that singleton in most of the cases is a design smell. Sure, but we are covering this pattern because it's one of the legacy patterns and we are using it for educational purposes. And of course, disadvantages of this design principle, why many people hate it, and I think hate is a good word, um, in this case is that first of all it's not thread safe, you will have to have some workaround, and also it's not particularly clear how you would deal with the destruction process of a singleton, which of course can be done. But with all these ins and outs, we are going to cover it to learn about one of legacy patterns. Okay, let's dive into the code. First of all, as you can see, I included already Google test header. So that is done. And before we start putting some code into our IDE, I would like to outline here first rules that we need to follow in order to produce a good singleton. Now notice I'm not advocating for a singleton, but if you decided to use it, let's do it properly. And here are the rules. First of all, we'll define a private static class instance. So important to note is that it will be private and static. Second, all constructors will be protected or private. Third, we will define a public and also static accessor function that we can publicly access, but it will use internally our private static class instance. Now, rule number 4, inheritance is okay, but static functions may not be overridden. Also, base class must be declared as a friend of the derived class to be able to access its protected private constructor. Fifth rule is that we have lazy initialization on demand. And sixth, to manipulate a singleton, a client, let's say our main function, may use only an accessor function that we provided here in the step 3. Okay, now we know all the rules, and normally people define from 5 to 10. I'm going to stick to this 6 in order to implement singleton properly. Okay, what we will be talking about, what is a physics example that we are trying to implement today? Well, let's say we are having in our event at the LHC some missing transverse energy, which is MET or MET, and there are several algorithms. We will be implementing MET algorithm, which uses particle flow objects, but also there is a variation of MET algorithm which is using colorimeter towers. So for us that will be 2 cases: MET algorithm, which uses particle flow objects, but also ColorMet algorithm, which uses towers in the equal. With that, let's get started. So MET algo uses PF objects, and ColorMet algo equal towers. Okay, the first class is MET algorithm. Now, what we will do, we'll take rule number 1 and insert it right here. Let's start with private fields. According to this rule, we will have static met algorithm pointer to met algorithm class instance that we will call, in order to have a proper name, we'll call it a single instance. Also, it's very important to keep it static, since one per class. Okay, now what else I would like to add is a string, and let's call it type, because we will be dealing, as I mentioned up above here, with two different types of met algorithm. And the final one is a string, and we will call it speed of calculation. And with that, I would like to differentiate two algorithms. If met algorithm with particle flow objects, we'll have to have all the particle flow objects in place, so it sort of will take lots of time. And Calo met algorithm will use only equal tower, so it will be a little bit faster. So it will be something like this is slow, and this is maybe medium speed. Okay, now let's move into protected section, and here is what we will do. We'll define a constructor. Let's define a constructor. I would like it to print out that we are constructing met. And also it's important, since we are dealing with the fact that we need just one and only one instance, when we define number of instances, for example field, it's important that we keep track of what that variable is over here. So what I will do, in a public, under public section, I will define again static int number of instances, and here inside of the constructor I would increment this variable. So we will be keeping track of how many instances of the class met algorithm we have produced. Okay, we have our protected section done. Now move into public. What I would like also to do is to delete copy constructor and I would like to delete copy assignment operator. With that, we will not be able to copy one object to the object at hand, and also we will not be able to assign some object to the objects that we deal with. So let's do it explicitly. We'll have meta algorithm const met algorithm reference equals delete, so we explicitly delete it. And here I would repeat the same for the equality operator. Again, const met algorithm reference and delete. Okay, that part is done. Now, finally, moving to the rule number 3, which is define a public static accessor function. We will have two variations. So we will have a standard variation where we get a pointer, but also we will have a sort of modified version, which is we'll get a reference. And actually reference is sort of a modern all agreed solution to Singleton if we are going with this pattern. But we will keep both because they both can exist. However, I will show that the version with the reference is much better and it works properly. However, the version with pointers can give some controversial error-like results. Okay, so now implementing accessor by reference. And this is a good way of doing it. Of getting the access. Okay, so we start again static, met algorithm, by reference, get ref. Now what we will do, we can create static object which we'll call reference to single instance, and we just simply return it. That's it. Now I would like to define accessor by pointer, not a good way of getting it. And what I will do a function declaration. So it's a pointer to met algorithm, get ptr, and we will define it outside of the class. Now, once we are done with that, what I would like to have is a couple of setters and getters. So let's start with, since we have a type variable, which is a string to define whether it's particle flow or colorimeter, color-based met algorithm. Let's start with the following. So we'll have a static function that returns void, and we'll call it setType. Now, since it's a setter, it has to have some parameters here. Let's have type in. And what it will do, it will take an existing type and set it to the following, the ones that we just provide. We will delete a previous, because if we are modifying a type, we don't need a previous instance, we will produce a new one. So we will delete the previous single instance. And also a good programming practice is to set it to null ptr after we just delete. Okay, so now moving to speed of calculation field. Let's have, actually, let's try to use ID. let's say getter and setter for speed of calculation. Okay, so here is our, let's call it set speed. So our set speed, it will take speed of calculation and it will set it. Now what about our get speed? Well, it will just return our speed of calculation. Notice this is a constant function. This is just a getter. Everything looks fine. We can move on. Now, remember, we still need to finalize a couple of points regarding static members. So the first point is that when we had that field single instance, we need to initialize it. So we'll do it the following way. Single, let's copy it. So we'll make sure there is no typos or anything. So we'll set it to null PTR. Now another field was string type. So we will do the string with algorithm met algorithm type equals to, as we discussed, particle flow. And finally, number of instances. So number of instances, it was under public static int. So we'll say again int met algorithm number of instances equals to 0. Now this is very important, like all these lines here, because otherwise it will be something like LD symbol not found for architecture x86-64. And this is sort of a bit confusing, but if you do get this, it's because you didn't initialize your static members outside of the class, which are declared inside of the class. So you keep them here, but you set them to default or null parameters outside. This is how you should do it. Okay, so we've done with this part, and then there is a second part, which is get pointer functions that we have to implement outside of the class. So let's have it, met algorithm, pointer, met algorithm, get ptr. Now we are going to follow our rule number 5, which is lazy initialization. So how we will do it? We'll say if not single instance and if type equals to particle flow, then single instance is equal to. So what we will get is a pointer to met algorithm, because if it's particle flow, it's just met algorithm for us. Else, our single instance equals to a different pointer, and we will call it, let's say, color math algorithm, and we will have to implement it. Now, after this is done, what we will do, we will just return a single instance. Notice if it exists, this code is not executed, and we will just return the one that does exist. Okay, now let's implement this color algorithm, color class. So we will have this class inherit from the main math algorithm that we defined at the start, and in the public section we will follow rule number 4. Here is our rule. What we have to do, we have to declare a friend class that our color class has the following friend. Like this. Now moving to protected section, we'll create a constructor. And here I would like to have some printing, which will do the following. It will say constructing math using color towers. Okay. And with that we completed rule number 4, and also we've got rule number 5. And let's see. That everything is correct. Okay. Now, finally, we can move to our rule number 6, which says to manipulate Singleton, we may use only an accessor function. And we actually implemented two, one by reference and one by pointer. And as I promised, I'll show you, we'll have some tests, and we will on purpose fail some and then fix it and run them to get situations where we have tests passing, and we will learn from these situations because this is where proper coding is. Okay, so let's have the following. Let's have auto, and you see we are creating ref algo. We'll use math algorithm get reference. Now notice this reference sign. This is crucially important because no reference sign results in a call to copy constructor. Now why this is bad? Well, the thing is, it is deleted, right? We on purpose deleted copy constructor and copy assignment operator, so that will be an error. Thus, this is very important. Okay, now that we've done that, what we will do is that we'll take ref math algo and we will set speed. Now, if this is particle flow, then we would say it's slow. Okay, well, it's relatively slow, right? It's all depends what we compare it to. And then we will do some printing, and we will say speed of the algorithm is, and we will do printing using the getter function. We'll take ref and we will do get speed of calculation. Okay. like that. Okay, so far so good. Now, however, at some point we would like to switch to a different algorithm. So we'll take this again ref, and we will set type to different one. We'll call it color, colorimeter based, right? And you remember, if it's not particle flow, then it will be a color pointer to colorimeter met algorithm object that is going to be produced. So, and after that, we will set speed, and this speed is medium, right? It's a bit faster. It's not as slow as particle flow, because particle flow needs way more things that has to be involved in the math calculation. Okay, we've done that. Now we will reuse printing line. The speed of another algorithm is again ref metal will get speed of calculation. Let's make sure that we have proper getter and setter, set speed, get speed of calculation, all is fine. Now what I would like to do, I would like to, on purpose, to create a couple of other references. So let's call it ref version 2. Okay, and we will use again this get by ref function, and let's copy paste version 3. And finally, we would print the following: number of created instances is. And remember, we have a number of instances variable, so this is where it comes in handy. We'll just print it and see how many variables we have. Alright, with that, let's go ahead and run our code. Okay, so we have constructing math. This is what happened over here. And then the line is the speed of algorithm is, and it is slow, and then we change the type. But when we change the type, as you can see, nothing got printed. And then we set speed to medium, and then we print again, and we see the speed of another algorithm is medium. So as you can see, nothing else got created. We are still using the same instance. And as you can see over here, the last line printed for us that number of created instances is 1, which is correct, right? It's singleton. We should have one and only one instance at a time. But now let's create our first Google test and test it there. Basically the same that we've done here, but just implement Google test, because it's a convenient way of doing tests which you'll use also later. How we will do it is the following. You say test, and you see we will have to provide test suite name and test name. So let's call it singleton test. And what we are doing, we are testing instances. Now, what do we do? Well, we create instance 1 with meta algorithm get ref, and we will do auto instance 2 with meta algorithm get ref. So it's basically the same what we've done here, just in one test suite. Now we will use assert equal, and you see takes two values. So first value we'll supply by hand, it's 1. And second is what our code should return us, and this is number of instances. And if it's 1, and it should be 1 since we already tested, but we wanna make sure we can also run Google tests, so we are doing it here. Now we completed our test part here. Now we just need to invoke it. How do we do it? Here is the way of doing it. Since we included test header, we have a testing namespace, and there is init Google test, which will take RxC and argv. And we already have in our main RxC and argv. So let's supply RxC and finish with argv. And we are done with the first part. And then the second part, the last part, is to return run all tests. And that's it. Right now, let's make it a little bit bigger. You will see we will be running some tests. And what I would like to do, I would like to remove this printing here so we can focus on a Google test part. Okay, let's run. Let's see what is happening. Constructing met. This is the line here. One test from Singleton. And that's all. It was one test and it is done. Now if we put here 2, of course it will be a problem because we know the number of instances is 1. Now we know this is running fine. What I would like to show is how we can get problems if we use get pointer function. So let's do it. Let's have the following: met algorithm get pointer, and remember it will return as a pointer, static instance, right, single instance, and we will set speed immediately to slow. Now let's get some printing involved. We will say the speed of algorithm is, here we will use met algorithm get pointer get speed. Okay. Let's comment out Google tests and see what we have with the following code. So you see what happened. We constructing met, we are constructing met, we are constructing met using color towers, and finally the speed of algorithm is slow. So it got confused completely. So first it's constructed as met, right? So which has happened here with get reference. Then at some point it was constructing met with color towers because we switched the type, right? And finally we decided to print what we are doing, and we've got this slow algorithm. So ultimately, if we print number of instances, it will not be 1. As you can see, it equals to 2 because first it was 1, and then second was invoking colorimeter towel, so it is 2. And of course, we cannot have two because this is, well, it's a purpose of a singleton to have just one. So with this, I just want to emphasize why this getPTR method is bad, and then I'm dealing with this pointer um, to static object is not a great idea over here. It's way safer to have a reference. So what I'm advocating is to use get reference at there. Also, what we can do is the following. We can go back to Google test. Like here, run again. And let's see what happened, as previously two instances are constructed, which should not be the case. Let's try again with maybe different setup for speed. What we can do, we can get PTR, we can set different type, and see that in this case we constructed one, then we move to the other one, and then one more got constructed, which is 3. So this is totally horrible, and we cannot accept it in our code. That's why all this stuff should be removed. And let's put it to ourselves. Do not use a bad practice or follow bad practice of get PTR. Now let's run this code. We can also, for fun, modify the type. Let's see if color works, and also change speed to medium, and we will see that nothing is changed. It still works, and it works well. As you can see, it's only one instance that got created. Number of created instances, 1. So with that, we can conclude on how we create a proper singleton, and also which variation of accessor function is better to use. Now let's do a quick recap. We started with the main class, which is MathAlgorithm. We followed our rule that we need to define a static class instance private. At the end, of course, we decided that working with this instance through and also using getPTR function to deal with it is not a proper or recommended way. Then we defined protected constructors. Also, we used this number of instances field to be able to know how many instances we are constructing, and it's a good cross-check to know that your code behaves well. Then we deleted copy constructor and copy assignment operator to be sure that through those methods multiple instances cannot be created. Then we defined the public static accessor function, one by reference, one by pointer. By pointer is a bad programming practice. Then we define setter and getter, both for speed of calculation and for type, just a setter. And to recall, it's about setting type, whether it's particle flow, so it's a meta algorithm, or color, which is color meta algorithm. Then we initialize static members outside of the class, otherwise we'll have this from the linker kind of confusing error message. Then we defined our child color met class. We are here basically practicing inheritance, and we shouldn't forget that we need to have this friend class meta algorithm to make sure it works well. Finally, we define our get ptr function. Now we know how to do it, even though we will not want and we will not be using it. Finally, we wrote here our test case. We defined a couple of instances, we modified it, and then tested with a third equal whether it works fine or not, and it does. And finally, in the main function, we started with testing the code manually by hand, but then we moved to the following. First of all, we learned that we shouldn't follow bad programming practice of using getPTR function. And second, we learned how to use Google tests. And Google test is a great framework providing us with different tests for C++. This concludes our series on creational design patterns. Singleton was the last. Next videos will be covering other types of design patterns, and can't wait to start discussing that and talking about them. But for now, thanks for watching. Stay hungry, stay humble. Till next time.